Hi class, this is Liz here, and this is week 14's discussion board solution. This is compound interest as a multivariable function. And let's go to the next slide. So our objective is to analyze an experiment with multivariable functions to understand and see how manipulating each variable affects the outcome of the function, and this problem will also show us a real-world use of the compound interest formula. This problem also allows for us to see how each variable plays a role in the solution and how changing each variable contributes to the outcome or output. So here is our solution. So for the first question, we want to find and interpret a parenthesis 2300, comma, 0.04, comma, 12, comma, 30 in real-world terms. So we know 2300 is the principal, 0.04 is the interest rate, so we have an interest rate of 4%. 12 would be compounded monthly, that's N, and then this would be T, so that's 30 years. This is the formula we're using right here, and you can go ahead and see that we plugged in all of the numbers into their variables, and we ended up with an output of $7,621.05. And in real-world terms, this means that by investing $2,300 for 30 years at an APR of 4% compounded monthly, you would end up with a balance of $7,621.05. So, question number 2. Here we're going to hold all the variables constant except one, and we'll do this for each one. So to start off, we're going to do P, which is the principal amount. Here our example is we changed P to 3,300, so we increased it by $1,000 to see how that's going to affect our future value. We plugged everything in, and our future value is $10,934.54. So that is an increase of, $3,313.49. So pretty good increase. When you go ahead and graph this, you will see a linear graph. As you increase P, A will also increase constantly, and the same if you decrease P, then you would see a decrease in your future value. So that one's pretty straightforward. Question 3 would be to hold R, or no, to hold all the variables but R, to see how R affects our future value. So in our example here, we're going to be using 8%. So we doubled our interest rate, plug everything in, and we get an output of $25,152.20. This basically means we tripled our original value, because originally we had around 7,000 and we now have 25,000 just by doubling our interest rate. So when you go ahead and graph this, you'll see that this grows exponentially, which means if you increase the unit just by 1%, then you're going to see a pretty big growth regardless. And for question number 4, we are seeing how N, which is a number of compounds, how that affects our A, our future value. So we did 2 examples for this one. This first one here, we are compounding 24 times, which means that would be bi-weekly, every 2 weeks. And you will see that the increase is pretty small. Originally we had $7,621.05, so this really only went up by around $7. In our second example, we used 52, which means that we're going to compound this weekly. And again, pretty small increase. Even from here to here, it's only a couple bucks. So there's not much of a difference here. N, which is a number of compounds, this can vary from days to weeks or months or years. Depending on the number of compounds, the graph may either shift in small increments more rapidly or rarely shift, but with a large increment of growth. So an example of a small increments would be to compound something daily. So your N value would be 360. a rare shift, but with a large increment growth, we would be compounding this yearly, so your end value would only be 1, but you'll see that all the interest is, or everything is added after the 1, so you're not going to see it. Your value will be very, I guess, your value will be larger. If your value is larger, so if your N is larger, then that means that you're going to see a very small growth because you're compounding it daily, which means you're adding that every single day, as opposed to waiting a whole year and then adding everything at the end. So this graph is actually increasing at a decreasing rate. So you'll see that there's not much of a change with N. Okay, so question 5, this is where we are going to see how time affects our future value. In our example, we did t equals 60, so we're going to be saving this amount for 60 years as opposed to 30. And you'll see that our future value basically went up to $25,252.31. So that's a pretty big increase, but it was a very big increase in time as well. This is doubling it, which, if you recall, we also doubled our interest rate and we almost got the same thing. Let's see. Yeah, so 25,152, and here we end up with 25,252 if we double our time. So this shows the effective t-year time on the formula. This represents the amount of time you have to let the account grow and accrue interest. The longer you let the account grow, the higher the future value will be. So if you save for a longer period of time, then you'll see that you'll have a higher future value. So this also is creating an exponential growth graph. However, this is not as steep as R. So let me see. So question number 6. Here we're just going to summarize every variable and how it affects A. P, as you possibly recall, that's a linear function and it's a constant slope. So as P increases, so does A. As P decreases, so does A. For R, that's our interest rate, and this variable had an exponential growth. So that basically means that it changes very quickly, which is going to help us in our next question. N represents the number of compounds, and this increases at a decreasing rate in relation to A. And then the t variable, which we just did, this is also an exponential function of A. However, like I stated, it is not as steep as R. So for this last question, finally think about this. In the above scenario, if you could increase only one of the inputs by exactly 1 unit, which would it be and why? So because R has a steeper exponential growth curve, that's what we went ahead and went with, because if we change our APR from 4% to 5%, that's going to give us the biggest difference. That actually increases our future value to $10,275.81. That's $2,654.76 more than what our original amount was with the 4% interest rate. And therefore, that's why we went with R. It wouldn't really make sense for us to just change P, the principal, to $2,301. We're going to see a really small growth with that. Time, of course, 31 years is better than 30 years, but you're not going to see as big of a difference as you would as if you changed R. So that is the entire solution for this week's discussion board. If you have any other questions, feel free to message us. And I hope you guys have a good week. Bye.